is one of the oldest buildings on campus. Built in 1941, it boasts 58 bedrooms on a 25,891 square foot footprint. It's well known for its location to the Duck, to the Woodpeck, and to McDonough Field. Let's go upstairs. As you can see, McTier lacks elevators, which is a good thing because elevators use electricity. However, it does also lack in green technology features that newer dorms such as Few and Evans have, like double flush toilets. However, there are some efforts to reduce energy use, such as using fluorescent light bulbs.
Turn it up. Welcome to the Math and Science Center. This 136,000 square foot building was created in 2002 and has a LEED certified rating. The Math and Science Center has recycling stations like this one on every floor, and the building itself was actually constructed using 75% recycled material. All the windows too here are double pane to help maintain insulation between the indoor and outdoor environment. The 5th floor of the building also has a rooftop garden which serves as an outdoor classroom. Additionally, the building employs a stormwater retention vault that helps with irrigation, as well as a closed-loop water cooling system that can help reduce water usage by 69% each year, saving up to 2.8 million gallons.
This is Few and Evans Hall. Opened in 2008, it is the first Emory University residency hall to receive the LEED Gold certification rating. It's 110,048 square feet, has 5 floors, has 180 rooms, and it has a low solar reflective red roof which allows it to help cool the building in the summertime.
Few and Evans has a recycling room on every single floor. And the paints and sealants were used with low VOC, which is volatile organic compound. And 84% of the construction waste was recyclable. Also, what's really cool, this terrazzo flooring was made from recyclable automobile glass. You know what? I kind of feel like using the bathroom. As you can see, these faucets are automatic. And the best part is the bathroom, which I'll show you in a minute. Oh, hey, come on in. So, as you can see, these toilets have a double flush system, which means that you lift up for liquid waste and down for solid waste. This project overall saves about 30% water. It's a great idea to be green. Let's go check out Professor Harding's environmental management course. He's doing a case study on Few and Evans.
Like I was saying, Samuel, where have you been?
I was in the bathroom.
Anyway, take a seat.
Sorry.
Let's continue. As I was saying, during the construction of Few and Evans residency halls, 280 tons of construction materials were diverted from area landfills. Additionally, these carpets that we see here hold a high recycled carpet fiber content. Also, in the exterior of the buildings, native Georgian plants were used to naturally filter the water. Lastly, the roof water is held in a bioretention area, which is near the residency halls and used in the toilets in the residency halls. Class dismissed.
Hey, look what I found. Check out these solar panels. These solar panels help pump the stored water in the bioretention areas to be used in the toilets. It's pretty cool, huh? As you can see, Evans has this really cool live building dashboard which displays, for example, total water use that day, which is 2,508 gallons. You can also look at electricity, which is, as you can see, about 379 kilowatt hours. You can look at heating. You can look at cooling. You can look at all the systems for Evans at the moment used in kBTU units. You can look at all the different LEED buildings on campus and how they compare. And you can look at how this dashboard system works. Pretty cool stuff. I'm here with Mr. Brent Zern, the environmental engineer for Emory University. And hi, Mr. Brent Zern, how are you doing?
Good, thank you.
Great. So one question I wanted to ask was that, like, how do you kind of design or gauge the efficiencies for a building that's a LEED building? Like, when you're building it, how do you determine what kind of efficiencies it will have, and how do you monitor to make sure what will be, if it's going to match those efficiencies or be less or more efficient?
Well, the first step is during design, we need to model what the energy and water usage would be using a similar non-green building. So there's a model that we use that cranks out these numbers, and it tells us what our proposed efficiencies are supposed to be. And so that's during the design phase. Then once the building's constructed, we monitor actual usage, and we compare the actual usage to the designed savings to see if we really are saving what we thought we would. And if we're not, then we have to go back in and tweak the systems and try to get everything back on track.
As you can see in this performance rating method compliance table for Few and Evans, the proposed design and baseline design have significant differences. The proposed design uses about 39% less electricity and costs 39% less than that. It also uses about 27.4% less steam and costs about 27.5% less than that as well. However, the proposed design uses about 388,488 ton-hours of chilled water, while the baseline design uses none. The end result is that the green proposed design is about 12% less efficient than the non-green baseline design. However, the proposed design does cost about 22.2% less.
One more question. So I'm looking at, you gave me this table for proposed versus baseline, and so proposed design is, the design if it had the green technology, and the baseline design is that if it didn't have the green technology when you're kind of creating this building. And so it says here that the proposed design uses about, here it says I think actually about 12% more energy than the baseline design, but it does cost about 22.2% less. So can you explain like why? I get a lot of people, the conventional thinking is that the proposed design is going to be a lot more efficient but actually cost more. So it's actually the opposite in this case, if you could explain that.
As you know from looking at our proposed design versus our baseline, the proposed design has 3 separate components to the energy system for the building, whereas the baseline only has 2. The most important thing to remember is that even though total energy usage for energy, steam, and chilled water in the green building is more than just the energy or the electricity and steam usage in the baseline building, the actual electrical use for the green building is much less than in the baseline building. And that's the most important thing, because here in the South, we have to purchase our energy from Georgia Power, and Georgia Power uses coal to produce electricity, and that is a severe environmental detriment. So the less electricity we can use, in all actuality, the greener the building will be.
Cool, great. Thank you so much.
You can't touch this. You can't touch this. You can't touch this. You can't touch this.